Hello friends, welcome to the 12th session of the function series. In this episode, we are going to take up a few questions on the parabolic functions. Okay, so let's get started here. So we have a question here wherein let's say that a ball is thrown from an initial height of 5 feet and it follows the trajectory as shown here. It reaches the maximum height of 6 feet at some point of time and then finally hits the ground anywhere between 0.5 and 1 seconds, right? So we have the situation and we have to find the equation of this parabola, right? So clearly, right, we know the vertex of this parabola, right? We know that at what time the ball reaches the maximum height, and we also know the maximum height, right? So we essentially know the coordinates of this vertex, which is nothing but 0.25, right, comma 6. So it makes sense for us to use the vertex form of the parabola. We all know that the vertex form of the parabola is y is equal to a x minus h whole square plus k, where h and k are the x and the y coordinates of the vertex. And here we know those coordinates. So h is 0.25 and k is 6, right? So essentially our parabola will look like this: 0.25 whole square plus 6, right? But we don't know the value of this constant a here, correct? So all we got to do is to find the value of a, and once we have found that, then we will have the equation of the parabola, right? Now, if we see here, we have another piece of information which we can use to find the value of a, right? And that piece is the height, the initial height from where the ball is thrown, right? So at time t equal to 0, right, the height, the initial height is 5 feet. So this point here, 0,5 is also a part of the parabola. So we can actually plug in this point here and solve for a, right? Let's do that. So let's plug in x and y as 0,5 here. So it will be 5 equal to a. 0 minus 0.25 is 0 minus 0.25, so minus 0.25 whole square plus 6, right? And then we solve it further. We bring 6 to the other side, so it becomes 5 minus 6, which is minus 1. So it becomes a minus 0.25 whole square is equal to minus 1, right? Because 6 comes this side. Now minus 0.25 whole square is nothing but 0.0625, right? Because 0.25 times 0.25 is 0.0625, and minus cancels out because the square of a negative sign is positive, right? And finally, we get the value of a as minus 1 over 0.625, 0.0625, which is equal to essentially minus 16. I mean, I'm not going into the details of these calculations, right? But this will come out to be minus 16. So essentially, we got the value of a as minus 16. Hence, the equation of this parabola would be y equal to minus 16 x minus 0.25 whole square plus 6. So this will be the equation of this parabolic function. Just to quickly reiterate, right, when we saw this parabola, we know that we have been given the vertex of the parabola. So we use the vertex form here. We know the value of h, we know the value of k. We plugged in the values here, and then we used this another point, 0,5, which is also on the parabola, to plug it into this equation to get the value of a. Once you get the value of a, we have the final equation of our parabola. Okay, so now let's reverse the situation, right? In the first question, we were given the vertex of the parabola and we had to find the equation of the parabola, right? Let's say that we have been given the equation of a parabola and we have to find the vertex, and also we have to draw the trajectory of the parabola, right? So we have a parabola y is equal to 2x square minus x minus 6, and we have to find the vertex and also draw the shape or the trajectory of the parabola, right? Now we know that the x coordinate of the vertex is given by minus b over 2a, right? So the x coordinate of the vertex is given by minus b over 2a, right? when the parabola is in the standard form, ax square plus bx plus c, in that case, this gives the x coordinate of the vertex. So in this case, where b is -1, so minus of -1 would be 1 divided by 2a. A is 2, so 2 times 2 is 4. So the x coordinate of the vertex is 1/4, right, or 1/4, right? Now we can plug in this value of x and find the corresponding value of y, which would give us the y coordinate of the vertex. So hence we will know the complete coordinate of the vertex. Let's do that here. So you will just plug in 1/4 square times 2 minus 1/4 minus 6, correct? So this will be 1/8 minus 1/4 minus 6, and we can solve this fraction to get 1 minus 2 minus 48 or minus 49/8, right? So roughly a little around -6, right? So we got the coordinate of the vertex right away. So the vertex coordinate would be 1/4 comma minus 49/8, correct? Or we can say, let's say 0.25 and roughly close to -6 dot something, correct? So we know the vertex of the parabola. Now how to find the trajectory, right? So for finding the trajectory of the parabola, we need to have a few more points, right? So we can join those points and get the overall shape of the parabola. So let's see if we can factor this quadratic, okay? So we can use the grouping method to factor this quadratic. So let's say we use that and we get to 2x square minus 4x plus 3x minus 6. Take 2x common here, x minus 2 plus 3 common here, x minus 2, and then we get finally x minus 2 and 2x plus 3, right? So we were able to factor this quadratic using the grouping method. Now to find the x-intercepts of this parabola, the value of y will have to be 0, right? X-intercepts are nothing but the points wherein any function cuts the x-axis and the value of y is 0 there. So when we plug in y equal to 0, we can find the corresponding values of x. So we get two values of x. One is 2, x equal to 2, and the other is x equal to minus 3/2. So these are the two x-intercepts of the parabola, correct? So now we can visualize the overall shape of the parabola, right? We know the two x-intercepts of the parabola. We also know the vertex of the parabola, and we know that this parabola will be going upwards because a is positive, right? So we can draw the shape of the parabola now. It will be something like this. So this is our y-axis, x-axis, 1, 2, 3, -1, -2, -3, right? 2, 0, this is our first x-intercept, -3/2 or -1.5. So let's say here, this is our second x-intercept, and our vertex is 1/4, which is 0.25. So let's say somewhere here, and our y coordinate of the vertex is -49/8, or let's say -6 dot something. So 1, 2, 3, 4, 5, 6. Let's say somewhere here. So this is -6. So this will be our vertex somewhere here, and these are the two x-intercepts. We know it will open upwards, so our parabola would be something like this, right? So just to quickly reiterate, right, we were given an equation of the parabola. We found the x coordinate of the vertex using -b/2a right away. Once we got the x coordinate, we can plug in that value to get the corresponding value of y. Hence we got the full coordinates of the vertex, correct? Now we factored this parabola, and we got the two roots of the parabola, or the two x-intercepts of the parabola, which gave us these 2 points, and then we join all these 3 points to get the overall trajectory of the parabola. Yeah, folks, hopefully you liked the video and you found both the examples meaningful and useful. The first example wherein we were given the vertex and the trajectory of the parabola, and we had to find the equation of the parabola, and in the second example wherein we were given the equation of the parabola and we had to find the vertex and also draw the trajectory of the parabola. Keep practicing, and in case you have any questions, please feel free to reach out to us at info.mathletes@gmail.com. See you in the next session.